All right, welcome. We'll go ahead and get started. We're going to go with the white background today, which lends itself well to the red and purple and maybe some blue. We'll see. And of course, everyone's favorite, the dark green. All right. So let's see. I'm going to look at number 2 on our practice page. It says how many formula units are in 120 grams of K2O.
Can we get a separate sheet of notebook paper?
It's up to you. Oh yes, you will need to work on a separate sheet of notebook paper. There is not enough room to work on that page. All right. You can work on the back for a while. Let's see. All right, so let's see. Click, click. How many formula units are in 120 grams of K2O?
You would just like write the column size
And then how many atoms? All right. So we've got all that, and I'm just going to highlight that and maybe increase the size of it just a bit. Okay, we're feeling Comic Sans today. I'm not usually a Comic Sans guy.
Well, why not? I like it.
It's very entertaining, but it's
Plus, they'll make the lowercase I and the capital, the lowercase I and the capital I look. The lowercase L and the capital I look.
All right. Hey, can we read that? How many formula units are in 120 grams of K2O? That 2 should, of course, be a subscript. And how many atoms? All right.
I think we can actually make it to a subscript, though.
So we will move on. We're always going to start with what we are given. So 120 grams of K2O. And then I'm just going to make a nice super long working line for there. Now, let me just real quickly remind you, you can go from grams to moles, and you can also go from moles to grams, and you can go from moles to particles. Ooh, that's kind of a little bit of a tore up P there, sorry about that. Or particles to moles. Remember grams to moles, we would use our molar mass. We would use our molar mass to convert between those. And to convert between moles and particles, we would use Avogadro's number, which of course is 6.02 times 10 to the 23rd. So we would use Avogadro's hashtag for that. And then you can also go from moles to liters of, you can go to volume of gas and back, but we are not going to worry about that right now because we've not studied that yet. So what we are worried about is grams to moles and moles to particles, or particles to moles and moles to grams. But you cannot go directly from grams to particles. There is like a gigantic wall in between there that you cannot get through. So you cannot go straight grams to particles. You must go grams to moles and moles to particles. Okay? Do we feel good about that? About that idea? Yes? You there, Emma? Okay, good. So what I need to do is I'm going to go grams to moles. Now I know that 1 mole of K2O, okay, I need to know the molar mass of that in order to make that transition. So how many grams of K2O are in 1 mole? And what I'm going to do is I'm going to look at the periodic table, and I'm going to say, hey, in K2O, I have 2 atoms of potassium, which is equal to 2 times, someone look and tell me, at, just do 2 decimal places, so what do I get? 39.10, okay. So 2 times that plus 1 molecule or 1 atom of oxygen, which is 1 times 16.00. And when I do the math on that and get it all together, I get 94.02 grams per mole. Yes, huh? Oh, excuse me, pardon me, you were right. 20, thank you, instead of 02.
So it's supposed to go 2 zeros?
Oh, well, no, because it's not 10, it's 01. And so then it would be 02.
What? 2 0? It's 10. Yeah, it's 10. It's 39.909.
39 point, okay, all right, 39.09, all right. Fine, I will humor you all, and we will put 20. Good job. Hey, thanks very much. Thank you for helping me with my rounding and my algebra. I appreciate it.
Algebra.
Well, 2 times 39.10. Can I at least have algebra for that? All right.
I thought that was just basic math.
Okay, fine. Thank you for helping me with my basic math.
Great.
Thank you for my 3rd grade math where we lined up the decimals and did the addition. Thank you. All right, so we're pressing on. So it's that many grams per mole of K2O, which is potassium oxide. All right, so let's see. Let's write 94.20 grams. And when we do the division there, then we'll see that our grams of K2O and our grams of K2O will divide away. And we will be left with just moles of K2O. So at that point, we're going to have moles. Well, so if you want, you can start a new fraction grid. I'm going to continue on this fraction grid, and I'm going to say, hey, 1 mole of K2O has how many formula units or how many particles? Now, we said that 1 dozen is 12. What is 1 mole? 6.02 times 10 to the 23rd particles, or in this case, formula units. A formula unit, just like if we talked about molecules of a covalent substance, when we talk about ionic substances, we have to talk about a formula unit. And I'll explain why in more detail a little later. All right. So if you want to think of that in terms of molecules, you can. It is not exactly the same, but it is the same concept. All right. Formula units of K2O. All right. So at that point, I will have 120. I will multiply by 1. I will multiply by Avogadro's number, and then I will divide by 94.20, and that altogether will give me about. Now here's the thing: I need to, because of the 120, that is 2 significant figures, and so I need to round to 2 significant figures, and so that's going to be 7.7 times 10 to the 23rd. Is that correct? Formula units. All right.
If we want to, can we just put E like 23? If we want
Yeah, you can. If you would like to use the calculator notation, that would be just fine. All right. I'm going to erase that for us real quickly. And I know, just like that. Now, this is the answer to the first part, 7.7 times 10 to the 23rd.
Should we write it like on here?
Yeah, go ahead and write that down. So you have that many formula units of K2O. And And I need to go to atoms. Well, here's my question. In one formula unit of K2O, which is K2O, how many atoms are there? 3. Okay, we see that there are 2 potassium and an implied 1 on the oxygen. Is that blue showing up all right? Yeah, it's okay, but it's not as good as Panther Purple. So K2O, we have 3 atoms per 1 formula unit. Ooh, that's bad handwriting right there. And so my formula units will divide away, and I will be left with just atoms once I multiply that by 3. And once I multiply that by 3, I think I end up with, let's see, let me see if I can erase just part of this or if this is going to kill my whole line. Yeah, there we go. And I think I end up with, let's see, about 2.3 times 10 to the 24th.
This must be 30 though, 30 atoms or 3.
Oh, that is 3 atoms.
Okay.
Anyone double check that and get that same?
That's what 2.29 round down.
So 2.29 will round at 2 significant figures to 2.3 because again at that point we had 2 significant figures. All right. Questions about that number 2? All right, do we need a moment to record that before we move on? All right, so let's see. Ooh. All right, so now I'm going to, I'll save this, so if you need it at the end, we'll come back to it. All right, so now I'm going to do one like number 6, but not exactly number 6, because I want you to be able to work that out a little later for your own practice. So I'm going to do one that is like number 6. All right. So again, let's. Oh, good. Our font is still the same because I would not want there to be any missed opportunity to use Comic Sans. So if I have 112 grams of sodium bicarbonate, how many grams of oxygen are present? All right. And let's love the punctuation and get that in there. So here I've got this one that's like number 6. If I have 112 grams of sodium bicarbonate, how many grams of oxygen are present? So let's see, 112 grams of sodium bicarbonate. Hey, for all those of you who said to yourselves, I'm so glad we're done with that nomenclature garbage. Wow, glad to get away from that. Welcome back, my friends. Oh no, jump on the bandwagon.
There's got to be an easier way.
Jump on the bandwagon. Hey,
After this test, we'll be done with moles.
so what?
We'll be done with moles.
No. Hey, everything that we're learning from now on through the end of the semester. Okay, all of it. And we're just going to keep adding more and more and more.
There's got to be an easier way for nomenclature though.
Nope. Hey, sodium bicarbonate. What is the symbol for sodium? Na. Ooh, there we go. Na. Now it is a +1. And then look on the back of your periodic table because you see that 8, and that tells you, hey, this is probably a polyatomic ion. HCO3, what is its charge? Hey, so look at there, it's a perfect match. So I can actually just go ahead and erase those charges. And I have NaHCO3. All right, the first thing that we're going to need to do in this, if we need to figure out how many grams of oxygen are present, that's going to be, we're going to have to do that by percentage. And so we're going to need to know how many grams of oxygen are present in the 1 mole of that. All right, so let's go ahead, because we need to have the same, it'll be the same percentage. So we can actually do this a couple of ways. The way we're going to start this, though, is I'm going to say, hey, sodium. Now, sodium has, what is the atomic mass or the atomic weight of sodium?
23. What is it, 23?
At that point, it will, no, it would be 22.99. 22.99. There we go. Hydrogen, 1.01. Hey, I want you guys to keep 2 decimals of anything that you pull off the periodic table. Okay? So any atomic masses that you pull off the periodic table, I want you to keep 2 decimal places. So hydrogen, that's 1.01. Carbon, that's going to be 12.01. Very good. And oxygen, whoa, I'm actually going to have 3 of them, but each one has a mass of 16.00. All right. And then we're going to total all that up and tell me what we come up with. .01. All right, I like it. And that is grams per mole of sodium bicarbonate. So the molar mass of 84.01 grams per mole. All right. At this point, there are 2 ways to work this. So I'm going to split the top and the bottom and work one of them in red and one of them in panther purple. All right. So let's go ahead and take a look here. One way is to do the percentage of oxygen. Now, 3 times 16 was 48.00. All right. So I'm going to say, hey, I have 48 grams of oxygen for every 84.01 grams of substance. And you can multiply it by 100 if you'd like. And what is my percentage? How much?
57.14.
All right, 57.14% oxygen by mass. Now, what I'm going to do is I'm going to take that and I'm actually going to convert it back to a decimal and say, hey, what is 57.14% of 112 grams? And that will give me the grams of oxygen. So do the math on that real quickly. And what do we get? How much? 63.99? All right, so 63.99 grams of oxygen. All right, excellent. Now, and that was what we were asked for. How many grams of oxygen are present? Good job. Yay us. Now,
Are you about to erase it now?
not yet, but I will soon.
Are you going to add something on it? Or you
I'm going to add on the bottom.
Okay.
Now, the next question is, I told you that there were 2 ways. The other way is you could have just set up a ratio and said, hey, 48 grams of oxygen in every 84 grams of molecule. Well, what if I have 112 grams of molecule? How many grams of oxygen do I have? And when you solve that for x, you will still end up with 63.99. Hey, here's what I want you to see. Watch the screen for a moment. Here, what I did is I created a percentage and then applied the percentage to my amount to get the grams of oxygen. Here, you're doing the same thing. You're creating a percentage and then applying the percentage to your amount in order to solve. So you're doing this exact same mathematics. It's just whether you would prefer to carry it out in a percentage application or whether you would prefer to set it up as a ratio. But in either case, it's actually the exact same mathematics. All right? And so that is that. Everybody copy down what you need or take a quick snapshot. I will post this in the Google Classroom at the end. Okay? All right, thank you. I cannot be present in any of the photos as I'm in the witness protection program, so please be sure that I am not, that I did not commit a crime. I testified against a crime. Okay? And I've already said too much. I can't discuss it any further. All right? I can't. I don't do that myself. Okay, so no. So no, I can't discuss it any further. All right. So at this point, let's move on to one that's going to be like number 9. Okay. So let's do one that's like number 9. I have not. No. No. So number 9, I'm going to actually say. I'm going to ask you to write the formula for nickel 2. Nickel 2 chloride hexahydrate. All right, so this is going to be a quick review of how we convert between the names and the molecular formula of hydrates. Okay, so we have nickel 2 chloride hexahydrate. Here's what you do: you write down the name of the compound, and then you write down the numeric prefix, and then you write down H2O for hydrate. Okay, so nickel 2 chloride. Now that's going to be nickel with a +2 charge. And then chloride, which of course has a -1 charge. And so when we crisscross those, we end up with nickel and NiCl2. So there's nickel chloride 2. And then we put our middle dot. And then hexa, what number does hexa represent?
6.
And hydrate refers to molecules of water. And so nickel 2 chloride hexahydrate is written in terms of the molecular formula like this. And that tells you that for every formula unit of nickel 2 chloride, that you would actually have 6 molecules of water trapped in the molecular lattice or in the ionic lattice. Okay? Questions about that? Now, if you saw it written this way, you would simply go the other direction. You would say, oh, NiCl2, that is nickel 2 chloride, and then hexahydrate. All right? And I'm not going to write that down again because it's written right up here. So whether you go from the name to the formula or the formula to the name, it's all about the compound, the numeric prefix, and the word hydrate. Compound, numeric prefix, hydrate. All right? So that is one like number 9, and you can once again work number 9 for yourself later. Last one that I'm going to do for us as a group, and then I'll turn you loose on the rest of the practice. Let's look at one like number 10. So again, I'm going to work one like number 10. And I'm going back to the green because everyone loves green.
I don't like green.
Green
Hey,
is
everyone likes green. Stop it.
Mr. Willis, you remember why I don't like green?
No, I don't want to know.
I don't like green.
But green is
Haters gonna hate. Jealousy is such an ugly color for you. All right. Hey. All right. I know. Speaking of jealousy, green is yeah. All right. Anyway, hey, like number 10. If I have 15.67 grams of magnesium carbonate, so 15.67 grams of magnesium carbonate is heated gently to drive off the water. Excuse me. So 15.67 grams of magnesium carbonate hydrate is heated gently to drive off the water. It then has a mass of, this is why I was typing a moment ago. It's all clear to me now. It then, I said, it then has a mass of 7.580 grams. What is the hydrate formula? Someone dropped a pencil and I almost said bless you. Bless you, poor soul, for the loss of your pencil. All right, so I know. I think we should. I mean, you know what? It's time to recognize the difficulty associated with the dropping of your pencil. All right. Hey, if I have now here's the thing. If I have 15.67 grams of magnesium carbonate, I really have 15.67 grams of magnesium carbonate hydrate. So what I really have is then 7.580 grams of magnesium hydrate and magnesium carbonate anhydrous. What's the formula for magnesium carbonate? Mg. If you look on the back, carbonate is a CO3. But what's the charge on a carbonate? But what's the charge on a magnesium? +2. So magnesium is a +2, carbonate is a -2. So they are once again a perfect match, and we can just leave them that way. However, we do need to know how much water we have. So let's go ahead and figure out how much water was present. So we're going to take the amount of hydrate we had and then subtract the mass of the anhydrous substance to get the amount of water. So everyone crunch that number real quick. And me and my basic math are getting 8.09 grams of water. All right, which means we had 7.580 grams of magnesium carbonate, 8.09 grams of water. And the first thing that we need to do, anytime we're going to talk about ratios of substance to substance, we cannot do that in terms of grams. We must do that in terms of moles. Okay? And so we need to convert each of these into moles. So moles of magnesium carbonate and moles of water. All right, let's see. 1 magnesium, which I'm just going to quickly do this on my calculator. Magnesium 24.31. Oh, and then my calculator went to sleep. Wake up. 24.31 plus carbon 12.01 plus 3 times 16.00. And I get 84.32 for the molar mass. Molar mass of magnesium carbonate. So then I will take 7.580 grams of magnesium carbonate. And divide by 84.32 grams of magnesium carbonate in 1 mole of magnesium carbonate. And that's going to come out to be
0.0, well, how many? 0.0, well, it would be 0.09.
Oh no, we need 4. We need 4 on this one.
Okay, so 0.0899.
0.0899 moles. Okay. So moles, I'm going to say there we've got 0.0899. All right. I'm going to switch colors for this one. A nice bright purple. Let's see. So 8.09 grams H2O divided by 18.02 grams of H2O in 1 mole of H2O. And what do we get? 0.4. Okay, so 0.449 on that one. Because I have 3 significant figures on that. All right. At this point, we have our moles to moles, but we need to divide by, so really what I've got is, and I could write them, if I were going to write them, I would need to write them as coefficients. But what we need to do is we need to divide by the lowest number of moles. So I'm going to take this and divide by 0.0899. And I'm also going to take that number and divide by 0.0899. And of course when I do, I'm going to get the number 1. And when I do that division, what do I get? So basically 5. So what that means is I've got 5 water molecules. I've got 5 moles of water for every 1 mole of magnesium carbonate. That means that my final answer will be, let's write it in a nice bright color here. Magnesium carbonate pentahydrate. All right.
So are we going to have there something where they'll have to write it out?
All right, that's going to conclude our examples, and then I'm going to take some questions here in class also. Don't forget tutorials after school and also virtually online.